Kermadec Islands, New Zealand, bracing for a catastrophic megaquake. In the endless blue expanse of the southern Pacific Ocean, halfway between New Zealand and Tonga, lies an arc of volcanic islands so remote and untamed that even the wind seems to hesitate before brushing against their shores. The Kermadec Islands Arc, a name steeped in myths and legends, is in reality a living laboratory of the Earth's raw tectonic fury, a place where the planet reveals its rebellious soul. This archipelago, made up of 4 main islands, Raoul, Macauley, Curtis, and l'Esperance Rock, and a constellation of submerged reefs and seamounts, serves as a bridge between the visible world and the unseen, between lush rainforests stretching towards the clouds and the oceanic depths where tectonic plates clash in an age-old dance. Here, nature reigns supreme, but its beauty hides a disquieting secret. In recent years, the region has been shaken by a series of catastrophic earthquakes, prompting scientists to ponder a future in which these islands might vanish, swallowed by tsunamis or shattered by colossal eruptions. To understand the fate of the Kermadec Islands, one must dive into their history, a story woven from fire, water, and stone, beginning 25 million years ago when the Pacific began to fold under the weight of Australia. All of this and more is showcased in this spectacular video, another gem in a series of videos dedicated to the deadliest seismic zones on the planet. Be sure to check out the collection on our channel in case you missed any. And now, let's head to the Kermadec Islands. In the vast expanse of the South Pacific's endless blue, stretching between New Zealand and Tonga, lies the Kermadec Arc, a volcanic island chain that runs 1,200 kilometers or about 745 miles from north to south. It begins at the triple junction with the Tonga Trench at 26 degrees south and extends down to the Hikurangi Trench near New Zealand at 37 degrees south. Just 1,000 kilometers or about 621 miles from Auckland, an hour's helicopter flight away. The islands feel remote yet connected. To the west, Australia is 2,200 kilometers or about 1,367 miles beyond the Tasman Sea. The archipelago consists of 4 main islands, but only Raoul, 11.4 square miles, has fresh water. The others are volcanic fragments: Macauley, 1.18 square miles, Curtis, 0.23 square miles, and l'Esperance Rock, a jagged sea stack 250 meters or about 820 feet across that juts out of the ocean like a broken tooth. The entire arc rests on a submarine ridge towering 3,000 meters or about 9,843 feet above the surrounding seafloor, with peaks plunging as deep as 10,047 meters or 32,963 feet into the Kermadec Trench, making it the second deepest trench in the world after the Mariana Trench. The Kermadecs are a sanctuary of biodiversity, protected by a 620,000 square kilometer, about 239,383 square mile marine reserve, an area nearly the size of Texas. Within these waters swim 35 species of sharks, 6 species of whales, and 12% of the world's fish species. Yet humans remain rare visitors. There are no surviving indigenous populations, and only a handful of researchers dare to live on Raoul, an island as large as Manhattan, to study seabirds like the exceedingly rare Kermadec petrel, or to monitor the island's ever-breathing sulfurous volcanic fumaroles. It's a paradise, though wild and unwelcoming, a paradise born of conflict, not metaphorical but geological. Here, the Pacific plate slides beneath the Australian plate at a rate of 60 millimeters or about 2.36 inches per year, a process known as subduction that transforms the seafloor into a cauldron of magma. This titanic collision has built layer upon layer of volcanoes that tower at nearly 1,000 meters or about 3,281 feet high, such as Mount Momukai on Raoul, whose summit vanishes into the mist. These giants are cloaked in tree ferns and pohutucata trees, an endemic species that burst with crimson blooms, while the crystalline waters surrounding them teem with life, humpback whales, pelagic sharks, and schools of kingfish darting through the currents. Before geologists decoded their secrets, the Kermadecs were a mirage for navigators, exiles, and dreamers. Between the 1300s and 1400s AD, the Polynesians were the first to sail these waters, calling the islands Rangitaua, or place of rest. Fragments of basalt axes and remains of umu, earth ovens, found on Macauley Island suggest they were temporary outposts, possibly used for seal hunting or collecting Tahoe bird eggs, now extinct. Yet the islands were far too inhospitable for permanent settlements. Volcanoes showered crops with ash, cyclones swept away shelters, and the waters were alive with sharks. Europeans stumbled upon the islands by accident. In 1788, the French ship La Marchande, en route to Tahiti, was pushed by currents onto Raoul Island, which Captain Jean-François de Surville named Ile de la Désolation. For decades, the islands became a refuge for whalers. In 1830, the crew of the Elizabeth reported witnessing mountains of fire rising from the sea during Macaulay's eruption, while the sailors brewed beer from the juice of Nicao, the endemic palms. Attempts at colonization ended in tragedy. In 1878, the Bell family from Scotland settled on Raoul with 50 goats and potato seeds. 3 years later, only 2 children, Mary and James, survived. In their journal, they wrote, "The earthquake swallowed our field, and the goats scream in the mist like damned souls." Abandoned in 1914, the island became a radio station for submarine cables, manned by operators who were driven mad by solitude. In 1944, a technician named Tom Walters shot his wife and himself, leaving a note about the demons singing in the fumaroles. Today, the only human presence on the Kermadec Islands is at the research base on Raoul, where 6 scientists live in metal containers, monitoring seismographs and battling invasive rats that threaten the nests of the extremely rare Rematara parakeet, reintroduced in 2007. The seismic fury of the Kermadecs is not a new phenomenon, but what alarms scientists is the acceleration of events in recent years, a sequence that seems to signal an impending catastrophic transformation. On June 15, 2019 at 10:55 p.m. Universal Time, a magnitude 7.2 earthquake tore through the seabed east of Raoul Island at a depth of 33 kilometers, or about 20.5 miles. The tremor, felt even in Auckland, caused no direct damage only because the islands are uninhabited, but it triggered a 1.5 meter or about 5-foot tsunami that swept across the shores of Curtis Island, destroying seabird nests and shattering coral colonies. 4 months later, on October 18, 2020, another quake, a magnitude 7.4, hit almost the same location, but closer to the surface, at a depth of just 10 kilometers, or about 6.2 miles. New Zealand seismographs recorded ground oscillations of 0.3 G, 1/3 of gravitational acceleration, akin to what might occur during the collapse of a building. For weeks, the waters around Macauley Island boiled with sulfurous gases, indicating that the quake had destabilized submarine hydrothermal vents. The real wake-up call came in March of 2021, when 47 earthquakes above magnitude 5.0 struck within a 72-hour period, all concentrated along a 150-kilometer or about 93-mile stretch of the arc. On March 4, 2021, a magnitude 8.1 earthquake, releasing energy equivalent to 1,000 Hiroshima atomic bombs, triggered 3-meter-high or about 10-foot tsunami waves that reached Tonga within 20 minutes. Meanwhile, on Raoul Island, meteorological station staff scrambled to the hills, watching as the sea receded by 200 meters, or about 656 feet, before a wall of water swept away their instruments. It was a glimpse of what might happen if the fault were to rupture in a consistent manner. Models developed by New Zealand's geological and nuclear sciences estimate that a magnitude 9.0 megathrust earthquake, similar to Japan's 2011 Tohoku earthquake, would release energy equivalent to 32 gigatons of TNT, enough to elevate the entire Kermadec Arc by 10 meters, or about 33 feet, within seconds, generating a tsunami with 800-kilometer or about 497-mile wavelengths. Yet the seismic history of the Kermadecs runs even deeper. In 1917, an eruption of Raoul's volcano coincided with a magnitude 7.6 earthquake that destroyed the few shacks built by European settlers, forcing their evacuation. Diaries from the time describe the sea howling like a pack of wolves and hills splitting open into streaming fissures. This is not mere legend. As far back as 1450, a similar event wiped out the Maori villages of Wangre and Manahiapua, burying them beneath 3-meter thick, about 10-foot layers of marine sand, still visible today in coastal outcrops. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. Today, INSAR satellites, a powerful technology for detecting surface deformation with millimeter precision, reveal that the western flank of Raoul Island is shifting seaward at 15 centimeters or about 6 inches per year, a deformation that often foreshadows catastrophic lateral collapses. The violence of these events is etched into the landscape. In 2022, a University of Auckland expedition discovered that Macauley Island's western coastline had risen by 4 meters, or about 13 feet, since 2015, creating a fossilized cliff strewn with dead shells and coral skeletons, silent witnesses to an ascent that is, in truth, a prelude to collapse. And there's no comfort to be found when the archipelago suddenly falls silent and the ground ceases to tremble. In March of 2024, the Kermadec volcano stopped emitting gas for 72 hours, an unprecedented event. Analyses revealed that a plug of solidified magma had blocked the fumaroles. "It's as if the Earth is holding its breath," tweeted volcanologist Laura Mitchell. 2 days later, a magnitude 7.8 earthquake broke the plug, unleashing an underwater eruption 8 kilometers or about 5 miles from Curtis Island. The event created a new seamount 450 meters or about 1,476 feet high, which was christened Tika, the burner in Maori. For scientists, it's a stark reminder that the system is unpredictable and that even silence here is a threat. Among these islands, there's even room for a spy story. During the Cold War, the Kermadec Islands were the stage for secret operations. Declassified documents from 2022 reveal that in 1971, a Soviet Victor-class submarine installed a seismic sensor on the floor of the Kermadec Trench. Officially, it was for geological studies, but its true purpose was to detect French nuclear tests in the Pacific. The device, discovered in 2009 by a New Zealand ROV, contained magnetic tapes with recordings of earthquakes from the 1970s, data now being used to compare historical seismic activity with modern patterns. The data shows that earthquakes above magnitude 7.0 have increased by 40% since 1980, says geophysicist Igor Pasternak. Today, China has established a monitoring station on Raoul Island, officially for climate research. However, according to a report from New Zealand's Security Intelligence Service, Beijing is allegedly seeking access to seismic data to map submarine routes for U.S. submarines. But the Kermadec Archipelago danger doesn't just come from the land, it comes from the sea. In 2021, a study by Italy's National Institute of Geophysics and Volcanology modeled an apocalyptic scenario. A magnitude 9+ earthquake along the Kermadec Trench could generate a tsunami capable of reaching New Zealand's shores within 90 minutes and Chile's in 15 hours. Waves of up to 30 meters, about 98 feet high, would not only erase the islands themselves, but also threaten millions of people across the Pacific. And this isn't science fiction. At the Wairau Bar site, archaeologists uncovered children's skeletons with fragments of coral embedded in their bones, evidence they were struck by a wave so powerful it hurled underwater material far inland. Today, GPS satellites show that the Pacific plate is subducting at an unusually steep angle, 45 degrees, increasing friction and, with it, the potential for a big one. Further complicating the situation is the Tonga High Pi volcano, located north of the Kermadec Islands. Its 2022 eruption, the most violent of the 21st century, demonstrated just how quickly a submarine eruption can destabilize entire regions. The shockwave from Tonga circled the globe twice, and its ash clouds darkened Fiji's skies for weeks, forcing planes to divert by 1,000 kilometers or 621 miles. Why then are the Kermadec Islands so vulnerable? The answer lies in their unique geological structure. Unlike other subduction zones, the Pacific Plate here is young, 25 to 30 million years, and warm, rich in hydrated minerals that release fluids as they descend into the mantle. These fluids lower the melting point of the surrounding rock, generating magma that is silica-rich, explosive, and unpredictable. The volcanoes of the Kermadecs may not share the notoriety of Vesuvius or Krakatoa, but their power is equal, if not greater. Take Macauley Island, for example. In 1830, it erupted with such force that its height was reduced from 1,100 meters, or about 3,609 feet, to just 238 meters, about 781 feet, creating an 8-kilometer wide or about 5-mile submarine caldera. A Royal Society report from 1842 described the event as an apocalypse of fire and water, with steam columns 15 kilometers or about 9.3 miles high, visible as far away as Samoa, 1,300 kilometers or about 808 miles distant. Today, seismic sensors detect intense hydrothermal activity near Curtis Island, a sign that magma is rising. When combined with a destructive earthquake, this energy could trigger a phreatomagmatic eruption, a violent explosion of steam and lava, capable of obliterating entire slopes. This isn't speculative. In 2006, a submarine landslide north of Raoul, documented by sonar from the research vessel Tangaora, confirmed that the volcano's flanks are unstable. A collapse of 5 cubic kilometers or about 1.2 cubic miles of rock, triggered by a quake, could generate a local tsunami with 50-meter or about 164-foot waves, according to NOAA, the National Oceanic and Atmospheric Administration simulations. The Kermadec Islands are often compared to other volcanic arcs, such as the Aleutians, the Japanese archipelago, or the Andes, but they carry a significantly higher level of risk. Unlike the Andean subduction zone, where the Nazca Plate carries sediments that help lubricate the fault, the Pacific Plate here is bare, increasing friction. It's like rubbing two pieces of marble together instead of 2 blocks of ice, explains seismologist Clara Yoon. The energy buildup is immense. And unlike the Aleutians, where subduction occurs at a slow 7 centimeters, about 2.75 inches per year, and volcanoes emit viscous lava, here the rate is 8 centimeters, about 3.15 inches per year. While that difference may seem trivial, when paired with younger oceanic crust, it creates a volatile mix of both effusive and explosive activity. For example, the Raoul volcano has a volcanic explosivity index, or VEI, of 5, similar to Mount Vesuvius, while Tonga Hapai near Tonga reached VEI 6 in 2022. Another comparison can be made with the Zealand Arc in southern Japan. Both regions are dominated by submarine volcanoes, but while earthquakes in Zealand are deep, 300 to 500 kilometers or about 186 to 311 miles, and related to slab tear, earthquakes in the Kermadecs are shallow, less than 100 kilometers or about 62 miles, and associated with the release of magmatic fluids. The true anomaly, however, lies in the presence of the Louisville Seamount Chain, a trail of extinct volcanoes that impacts the Kermadec Trench, creating a thermal barrier. These seamounts, composed of tougher rock, temporarily reduce friction, only to unleash rebound earthquakes when they finally give way. A similar mechanism was observed in Chile, where the 2010 Mal earthquake, magnitude 8.8, was amplified by the subduction of the Juan Fernandez Ridge. For the few people living in the shadow of the Kermadecs, the coastal inhabitants of New Zealand, Tonga, and Fiji, the risk looms as a constant presence. My grandfather used to tell me stories about the waves that swept away houses in 1960, says T. Rangai Hotier, a Maori fisherman from Gisborne, New Zealand. Now they've put up sirens, but if a 30-meter, about 98-foot wave comes, what can we do? Run for the hills and pray. In the village of Tologa Bay, elders pass down a Waiata song that involves Tangaroa, the sea god, to calm the monsters of the deep. But faith alone isn't enough. In 2022, a New Zealand Herald survey revealed that 68% of coastal residents didn't know how to respond to a tsunami warning. To address this, in 2023, the New Zealand government launched the Moana Rua project, a smartphone alert system integrated with the Kermadec seismograph that provides 15 minutes of advance warning. Just enough time, perhaps, to find higher ground and avoid the flood. Even so, the New Zealand government admitted in 2023 that such measures would be woefully inadequate. A detailed simulation of a scenario with 35-meter, about 115-foot waves demonstrated chilling effects on both coastal areas and populations. Raoul Island would be first devastated, then completely submerged in just 8 minutes. Auckland, New Zealand would have 90 minutes to evacuate 1.2 million people, but currently only 12% of its coastal roads are classified as quick escape routes. Fiji and Tonga would face tsunamis with waves around 10 meters, about 33 feet high, and lose 50% of their freshwater reserves to saltwater contamination. Meanwhile, on Raoul Island, researchers are testing underwater drones capable of mapping fault deformations in real time. It's like having a stethoscope on the Earth's heartbeat, says Australian volcanologist Mark Hemer. One such drone, Taniwha 2, detected a 12-kilometer long, or about 7.5-mile fissure along the Kermadec Trench in 2023, where sensors recorded a pressure of 1,100 bar, enough to crush a submarine like a soda can. But the real challenge is political. In 2015, New Zealand proposed creating an international marine sanctuary around the Kermadec Islands, which would ban industrial fishing as well. The initiative collapsed under pressure from mining companies, which had their eyes on gold and silver deposits near underwater volcanoes. According to a confidential report from New Zealand's Department of Internal Affairs, in 2018, the mining company Nautilus Minerals estimated that the Kermadec hydrothermal vents contained 20 tons of gold and 1,500 tons of silver. But extracting these resources would mean drilling into active volcanoes, a reckless gamble. Protecting this area isn't just an ecological issue, warns marine biologist Maria Sanchez. Healthy coral reefs absorb 70% of a tsunami's energy. Destroying them to mine minerals would be suicide. At the same time, the Maori Ngati Kuri tribes are fighting in court to gain kaitiaki, guardianship status over the Kermadec Islands, citing the 1840 Treaty of Waitangi. These islands are tapu, sacred, explains leader Hone Harawira. They are the threshold between the world of the living and the ancestors. Defying them would be madness. The Kermadec Islands Arc serves as a fragile reminder of our existence on a living planet. Every tremor, every plume of smoke is a warning. The Earth doesn't ask for permission. For scientists, protecting these islands means unlocking the deepest secrets of subduction, perhaps the key to predicting future disasters. For the rest of us, they symbolize ephemeral beauty, a place where the breath of the world makes itself felt with unimaginable force, and where the future, like the clouds that shroud Raoul, hovers between light and darkness. As the Maori poet Hone Tuwar wrote after visiting the archipelago, "Here the gods walk underground, and their footsteps are drums that beat for us or against us." Today, those drums are louder than ever. In 2024, an international consortium of 15 countries launched the Te Moana Nui a Kiwa project, installing 150 seismographs on the Kermadec seafloor. It's the most advanced monitoring system in the world, says coordinator Hiroshi Sato. But even if we predict the earthquake, we won't be able to stop it. All we can do is listen and prepare.